Hello friends, I am Mr. Vedanta Kumar Bora, Associate Professor, Department of Chemical Sciences, DR College, Assam. So in this video, I will be discussing a very important chapter for the beginners of both chemistry and physics, that is the structure of atom. So in both these subjects, whether it is a chemistry or whether it is a physics, it is important to learn the structure of atom, how it is discovered, and what are the subatomic particles in atom. So as you know, today the knowledge we have regarding atom, that atom is the smallest individual particle of matter. Each atom is made up of some negatively charged particle called electrons, positively charged particle called protons, and neutral particles called neutrons. But whole picture of atom as we know today, it is not an outcome in the single strike of the hammer. It is a collective work of renowned physicists and chemists and also philosophers in the later part of the 19th century to the beginning of the 20th century. So the achievements regarding the structure of atom, the credit goes to John Dalton, Sir J.J. Thomson, Goldstein, Ernest Rutherford, Bohr, Erwin Schrödinger, Planck, etc. So I will try to discuss vividly the picture of today's atom and how this is established by the collective works of the gentlemen starting from the end of the 19th century. So this is my topic today, atomic structure. This is my topic today, atomic structure, or precisely the structure of atom. Now already we have understood what is the meaning of atom. Atom, we say it is an indivisible particle of matter, and this definition was given by John Dalton in the later part of the 19th century. But the story begins far before them. Who studied atom? Now the main question comes, who studied atom? So it is studied by many scientists for centuries. The earliest man was Democritus. It was in 400 BC. He introduced the term atom. He introduced the term atom, which means indivisible. Then Rutherford in 1911, and before Rutherford, electron proton was discovered, and the credit goes to Sir J.J. Thomson. Then Rutherford carried the famous scattering experiment, and he discovered nucleus. Then Moseley, he treated matter with X-ray. Then Niels Bohr, the famous physicist, he proposed the planetary model of atom. And after Bohr, the latest description of atom is through the Webb model of atom, and the credit goes to Erwin Schrödinger. It is in 1923. So before the discoveries came, the early Greeks thought that everything is made up of four basic elements. It is earth, air, fire, and water. So slowly, the definition changed. New concept came, new ideas came into the mind of the famous scientist, and slowly, people started discovering the constituent of matter. And it started in the 460 BC, Democritus. He grinded matter by using mortar and pestle until it reduced to very small particles which could not be further subdivided. For example, if you take sugar, If you take sugar in a mortar and you grind it using a pestle, then at one stage you will get a powdery material, and this powdery material contains some indivisible particles, and which Democritus called as atomos, means which cannot be further subdivided. So the word atoma, it comes from a Greek word which means indivisible, atoma or atomos. Democritus and Epiphanius thought that matter was discontinuous or made up of indivisible particles. So as you can say, a brick wall, it is not a continuous particle. It is made up of bricks. So these gentlemen, Democritus and Epiphanius, they were Greek philosophers, and they advocated the matter is made up of tiny indivisible particles which could not be further subdivided, and these particles were called atoma, and the word atoma in Greek word means indivisible. So this is the starting of the journey of discovery of atom, and it started with the word atoma introduced by the Greek philosopher Democritus, who grounded matter using mortar and pestle, and ultimately he got some very, very tiny particles, and he advocated that these particles cannot be further subdivided, and he called them as atoma, which means not divisible. In 1808, John Dalton, he suggested that matter was made up of tiny spheres that were able to bounce around with perfect elasticity and call them atoms. So in the 400 BC, Democritus, he introduced the word atoma, and he advocated that matter is discontinuous and it is made up of indivisible particles which were called atoma. And that theory was further forwarded by John Dalton, and he suggested the atoms are very tiny spheres which can bounce with one another with perfect elasticity and call them atom. Then this gentleman came in the picture. It is Sir J.J. Thomson, which is Joseph John Thomson. He has a son too. He is J.J. Thomson, and they both won the Nobel Prizes for physics. So at the time, people were curious to understand the conductivity of matter, and they want to find out whether gases conduct electricity or not. So had gas conducted electricity, we could not have used electrical switches, because in between the electrical switches and me, there stands air. And if air conduct electricity, then I would have got electric shock. But this is not the case, because air does not conduct electricity under normal atmospheric pressure. So people, especially crooks, you want to study the conductivity of gas at low pressure. And the result, it led to discover of some tiny negatively charged particles, which today we know as electron. So the cathode ray experiment led to the discovery of negatively charged particles, which were called electrons. And the credit goes mainly to Sir J.J. Thomson, Mulliken, etc. Now we will discuss how electrons were discovered. What is a cathode ray experiment? So this is a cathode ray tube. It is around 60 centimeters in length, which is fused at both ends, and they carried some metal electrons. So this is a tube which is sealed at both ends, and each end it carries some metal electrons. And there is an outlet, and through this outlet we can connect it to a vacuum pump so that we can suck the air inside and you get a vacuum inside the tube. And these two electrodes were connected to a very high potential difference of around 10,000 volt or 10 to the power of 4 volt. So under normal condition, electricity did not flow from the cathode to anode. Then they sucked out the gas inside by using a vacuum pump. And when the pressure was reduced to around 10 to the power of -2 atmosphere, some greenish rays travel from the cathode towards the anode. And when this pressure was further reduced to around 10 to the power of -4 atmosphere, then invisible rays travel from cathode to the anode, which could cast the shadow of any object placed in their path. So this is called the cathode ray experiment. This is the cathode ray experiment. Just I will show you another slide. This is the cathode ray experiment. So this is a glass tube which is around 60 centimeter in length, and it has two metal electrodes at both ends. And these two metal electrodes are connected to a very high potential difference of around 10 to the power of 4 volt. And when the pressure was reduced to around 10 to the power of -4 atmosphere, then invisible rays traveled from the cathode towards the anode, and these rays could cast the shadow of any metallic object placed in their path. So if you put a ball, iron ball somewhere here, then you will find the shadow somewhere here. That means rays are traveling from the cathode toward the anode. So this is how cathode ray was discovered, and these rays were called cathode rays. Why they were called cathode rays? Because these rays travel from the cathode towards the anode, and they believe that the cathode rays originated from the cathode and travel toward the anode. So they call these rays as cathode rays. So cathode rays are produced in a discharge tube where pressure inside is reduced to about 10 to the power of -4 atmosphere. And when a potential difference of around 10 to the power of 4 volt, that is 10,000 volt, is applied, then invisible rays travel from cathode towards the anode. And these rays were called cathode rays because they were believed to originate at the cathode, because they were traveling towards the anode. So a cathode ray, then I will come to later on, this is a beam of electrons. Okay. Then what they did, they applied an electric field by using two plates. This is one plate, this is one plate, and this plate is connected to a positive terminal of another battery, and this is a negative plate which is connected toward the negative plate of another battery. So in absence of electric field, the cathode ray travel in straight line. Here you can see it. But when an electric field is applied in between two parallel plates, so this is one plate, this is one another plate, they are parallel, and this plate is connected to the positive terminal. So this plate is carrying positive charge, and this plate, it is connected to the negative terminal, it is carrying negative charge, and the cathode rays is found to bend toward the positive plate. So in absence of electric field, the cathode rays travel in straight path. But when an electric field is applied around the cathode ray between two parallel plates, then they found the cathode rays got deflected toward the positive plate. So from this experiment that cathode ray get attracted toward the positive plate, it was established that cathode ray contains negatively charged particles. Otherwise, had the particles been neutral, then the cathode ray would not have got deflected. Now, when the electric field was applied, cathode ray got deflected toward the positive plate. That means this positive plate attracted the cathode ray. Then cathode ray must have contained negative charges. So this is the cathode ray experiment. So this is the cathode, this is a slit, this is the anode, and this is an outlet through which the air can be sucked out. And when a high potential difference is applied, around 10,000 volts, and the pressure inside the cathode ray tube is decreased to about 10 to the power of -4 atmosphere, then rays travel from the cathode toward the anode, and these rays were called cathode ray because it was believed that these rays originated at the cathode. Now what they did next, they put a blade somewhere here, and they found that this blade was deflected. It moved. Actually, they placed a paddle wheel here, and when the paddle wheel was placed in the part of cathode ray, then the paddle wheel revolved. It was set in motion. So here, this is another experiment. A blade, it was hanged in the part of the cathode ray, and you can see that this blade caused motion. This means this cathode ray must have contained some particles, and these particles hit this blade, and as a result, these blades caused to deflect. So from this experiment, it was established that cathode ray contains particles, and these particles must have been negatively charged, because in our earlier experiment we could see the cathode ray bend toward the positive plate, and now this experiment shows that cathode ray contain particles, because if we place a paddle wheel in the part of cathode ray, it got deflected. That means these blades must have been shot by some particles. These blades must have been hit by some particles, so it gone into motion. So this was the experiment, which was in 1897. J.J. Thomson placed a positively charged plate on one side of the tube and negatively charged plate on the other side. The beam was deflected from the negative plate toward the positive plate, and Thomson realized that the particles that made up beam must be negatively charged because they were attracted toward the positively charged plate. So the cathode ray was discovered due to the urge of the peoples to understand the conductivity of gas. They took different gases in a discharge tube, and discharge tube consists of a glass tube of around 60 centimeters in length, where pressure is reduced to around 10 to the power of -4 atmosphere, and the discharge tube had 2 electrodes at both ends. And when a high potential difference of around 10,000 volt is applied, then invisible rays travel from the cathode towards the anode. And later on, it was found the cathode ray contains negatively charged particles. Then Sir J.J. Thomson, he applied both electric field and magnetic field, and he was able to calculate the charge to mass ratio, because the cathode ray contains charge because it was deflected toward the positive plate. They also contain particles because a paddle wheel ran into motion when it was hit by cathode ray. So it was established that cathode ray contains particles which are negatively charged. So Sir J.J. Thomson then applied simultaneous electric field and magnetic field, and he was able to calculate the charge to mass ratio, that is called the E by M. E stands for charge, M for mass, that is E by M ratio of the electron, of the cathode ray particle, and it was found to be 1.7584 into 10 to the power of 11 coulomb per kg. And he found that the E by M value for cathode ray was independent of the nature of gases inside the discharge tube, that is the cathode ray tube. So whether it is a hydrogen gas or whether it is oxygen gas or whether it is a nitrogen gas, or whether it is a helium gas. That means E by M ratio for different gases was same. That means irrespective of the nature of gases, the particles constituting cathode rays were same. That means the particles of cathode rays were same, which is present in different types of gas, and later on these particles were called as electron. Actually, this name electron was given by Stoney in 1928, and J.J. Thomson discovered electron in 1897, and he called this particle as negative corpuscle. And later in 1923, sorry, it is not 1928, 1923, Stoney gave the name electron. So this is the cathode ray experiment. This is the discharge tube. This is the 2 electrodes at 2n. One electrode collected to the negative terminal, which is called the cathode. The other end collected to the positive terminal, which is called the anode. And the rays travel from the cathode toward the anode, and they were called the cathode rays. And it was established that the cathode ray consists of negatively charged particles, and these particles did not depend upon the type of gas inside the discharge tube, and these particles were later on called as electrons. So these are the properties of cathode ray which we are discussing now, and this is the apparatus which was used by Sir J.J. Thomson. This is a cathode ray tube, and these are the electric charged plates, and this is a magnetic field it is applied. So the electric field and magnetic field are perpendicular to the direction of cathode ray. So cathode ray travel in this direction, and to the perpendicular to the cathode ray you have an electric field, and also to the perpendicular to the cathode ray we have a magnetic field. And by simultaneously adjusting the electric and magnetic field, Sir J.J. Thomson was able to calculate the charge to mass ratio. And later on in 1906, Robert Mulliken, he carried the famous liquid drop experiment, and through liquid drop experiment he could calculate the charge of electron, and he found that the charge of electron was 1.6 into 10 to the power of minus 19 coulomb. So Sir J.J. Thomson, he calculated the charge to mass ratio, that is E by M ratio, and Robert Mulliken in 1906, by the famous liquid drop model, he could calculate the charge of electron, and he found the charge of electron was 1.6 into 10 to the power of minus 19 coulomb. And by working the E by M ratio, it was E by M ratio was 1.7584 into 10 to the power of minus 11, and Mulliken found that the charge of electron was 1.6 into 10 to the power of minus 19 coulomb. And so the mass of the electron could be calculated, and the mass of electron was found to be 9.11, precisely it should be 9.106 into 10 to the power of minus 31 kg. So this gentleman, Sir J.J. Thomson, he discovered that matter is made up of atoms, and in terms, atom contains some negatively charged particles, and these negatively charged particles were later called as electrons. And these electrons, they carry a charge of 1.6 into 10 to the power of minus 19 coulomb. And this charge of electron was calculated by Robert Mulliken in his famous liquid drop model. And Sir J.J. Thomson, he calculated the charge to mass ratio. So by putting the value of charge, he found that the mass of electron is 9.106 into 10 to the power of minus 31 kg. So this is the experiment of Mulliken, Robert Mulliken, that is a liquid drop model. Then after the discovery of cathode rays, the scientists had a curious mind. Then they wanted to do the experiment by doing little modification in the cathode. So this is the same cathode ray. This is the same cathode ray tube. This is the discharge tube. This is the cathode. This is the slit. This is the anode. So cathode ray travel from the cathode towards the anode. It passed through the slit and then gradually it moved toward the anode. Now, few physicists like Goldstein, what they did, they used a perforated cathode. Perforated cathode means the cathode which contains fine holes. These are the holes. And they repeated the experiment. Then what they found, in addition to cathode ray travel from the cathode towards the anode. These are the cathode ray. This is the direction of cathode rays. They are traveling from the cathode toward the anode. This is the slit. They also observed that some invisible rays were observed behind the cathode. And these rays traveled in a direction opposite to the cathode. So cathode ray traveled from the cathode towards the anode. And when the discharge tube experiment was used by using a perforated cathode, then invisible rays were observed behind the cathode, and these rays travel in direction opposite to the cathode. So people believe that since the cathode ray travel from cathode to anode, these rays were found to be traveling in direction opposite to the cathode. They assume that these rays must have originated from the anode. That means these rays is traveling from anode towards the cathode. So they call them as anode rays. And some also call them as canal rays because these rays travel through these perforated holes in the cathode, which were called canals. So people discovered that when you carry the discharge tube experiment using a perforated cathode, then rays similar to cathode rays were observed behind the cathode. And they have assumed that these rays must have originated from the anode. They call them as anode rays, and few people also call them as canal rays. Later on, it was found that these rays, they were deflected by magnetic field, they were deflected by electric field, and of course the deflection was opposite to cathode rays. Cathode ray deflected toward the positive plate, and it is due to that cathode ray contain negatively charged particle called electrons, and the positive rays, they deflected toward the negatively charged plate, which means cathode ray contains positive charge. So then people also call these rays, anode ray contain positive charge, so they also call them as positive rays. So similar to cathode rays, anode rays were also found to contain particles. So cathode ray contain particle, anode ray also contain particle. Cathode ray contain negative charge, but anode ray contain positively charged particle because they deflected toward the negatively charged plate. The deflection caused by magnetic field to cathode ray was opposite to the deflection caused by magnet to the anode rays. So it was believed that anode ray contains positively charged particle. Then they calculate the E by M ratio, and for cathode rays, it was found that E by M ratio did not depend upon the type of gas inside the discharge tube, but for the positive rays, the E by M ratio, it depends solely upon the nature of the gas inside the discharge tube. And it was found that E by M ratio was smallest for hydrogen gas for anode rays, and the particles of anode rays produced by hydrogen gas, and they were called protons. So this is how proton was discovered. This was how proton was discovered from positive rays. So they were called canal rays because it was passed through canals. Canal rays were positively charged particle because the deflection carried by electric field was opposite to cathode rays. So this is how canal ray originated. This is the experiment. This is the perforated cathode. This is the anode, and cathode ray traveled from cathode toward the anode, and some rays were also obtained behind the anode cathode, and these rays were called the anode ray because they believed that these rays originated from the anode and traveled toward the cathode. And later on, by applying magnetic field and electric field, it was found that the anode rays contain positively charged particle, and the smallest positively charged particle was produced by hydrogen gas, and these positively charged particles were called protons. Then the discovery of electron and neutron took place in 1932, long back. After 26 years, discovery of electron and proton, James Chadwick, he discovered neutron, and he discovered neutron not by cathode ray experiment but by bombarding beryllium with alpha rays, and beryllium was converted to carbon nucleus and some neutral particles emerged, and these neutral particles were called neutrons. So today we have this knowledge regarding the subatomic particles. Electrons, they have a mass equal to 9.106 into 10 to the power of minus 28 gram, and it has a charge of minus 1.6 into 10 to the power of minus 19 coulomb. This minus means negative charge. Proton, it is much heavier than electrons. They have a mass of 1.672 into 10 to the power of minus 24 gram, and their charge is equal to the charge of electron but with a positive charge. And neutron, slightly heavier than proton, it is 1.674 into 10 to the power of minus 24 gram. They do not carry any charge. And proton is 1840 times heavier than mass of electron. So in today's lecture, I discussed how the concept of atom originated. The concept of atom originated from Democritus, and later John Dalton proposed the Dalton atomic theory, and he proposed that matter is made up of elastic spheres called atoms. Then in 1897, people wanted to understand the conductivity of gas at low pressure. They carried the digestive experiment, and from the digestive experiment, they could discover electron. Then the digestive experiment was carried by using perforated cathode, and they observed some invisible rays behind the cathode, and they believed that these rays originated from the anode. They call them as anode ray, they call them as canal ray. And later on it was found the positive rays contains positively charged particle whose mass depends upon the type of gas inside the discharge tube, and the lightest gas, hydrogen, produced the lightest positively charged particle, which is called the proton. And after 26 years, it was in 1932, James Chadwick discovered neutron, not in the discharge tube but by bombarding with beryllium foil with alpha rays. And alpha rays are nothing, they are double positively charged helium ion, and a nuclear reaction took place, and beryllium was converted to carbon, and some neutral particles were ejected which have mass equal to that of proton, and these neutral particles were called neutrons. So in my next class, I'll be discussing how electron, proton, and neutron constitute atom. There I will be discussing the famous scattering experiment by Rutherford. I'll be discussing Planck's quantum theory. I'll be discussing photoelectric effect, and I'll be discussing Bohr's atomic theory. So until then, goodbye. So I promised I will be back with another lecture in this series. And if you like this video, please subscribe it so that you can get timely information.